So let's talk about what a content security policy is, why it's a good thing, how you'd implement it, and why most people aren't doing it. Okay. So if we think about a web application, normally what happens is you make a request, some sort of response comes back, which is say a page, okay? Then that page ends up making additional requests for additional resources, right? That page pulls down a JavaScript file and a CSS file, and then another JavaScript file, and some images, and maybe an audio file, and maybe, a whole bunch of stuff, right? Come down. Okay. And it could be some of your JavaScript, could be JavaScript for like Bootstrap and jQuery and all the other things you're using. All right. So a content security policy is a way that the server can tell the browser, when it comes to obtaining additional resources, these are the places that you can get those resources from. So for example, if this page goes to get additional JavaScript, it can only come from here. And when it goes to get images, they can only come from here, right? And you can get much, much better control over where these additional sort of resources come from. But basically, it specifies the sources that the browser should trust for additional content, okay? It's very cool, okay? Super good idea, right? And it's done, again, via header. So basically, the server just returns this header, and this header, content security policy header, includes a policy as the value of the header that specifies, what's cool, right? So what does this look like? Okay, so the first thing is it should include this default source directive. So here it says default source self, okay? This guy right here, okay? Now, just with this, what this tells the browser is you can only get additional resources from the same origin of where this page came from. So if the page came from foo.com, everything else has to come from foo.com. If it tries to load a resource from anywhere else, it ain't gonna work, okay? Now, the other thing with this though is, notice this first bullet here. Using a CSP will disallow the use of inline scripts and styles. Okay, now, that's the reason why most people don't use it nowadays, okay? Because here's the thing. We can specify this policy about where stuff can come from, but it's all useless if we can't disallow inline scripts and styles. Because if somebody's a man in the middle and I can inject some script into the page, well, that's not coming from somewhere else. That's just me injecting stuff into the page, right? And so that is sort of rule number one, which is if you're using a content security policy, we cannot have any inline scripts or styles. Now, if you talk to most modern web developers, what they will tell you is, well, you shouldn't be doing that anyway, because that's just good, clean web development. All your JavaScript should be stored in separate files, and you should be using non-obtrusive JavaScript that attaches functionality to different elements in the page, blah, 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 right? All your styles should be in separate CSS files. That's the way you should be doing your web development anyway, for lots of good reasons of just organizing your code and making things nice and clean and beautiful and whatever, right? But this is why a lot of people aren't using this nowadays, is because they've got existing web applications that have a whole bunch of inline scripts and styles. And they're like, well, yeah, we should probably move away from that, but oh my gosh, it's going to be a huge amount of work to move all that stuff out of those pages and into their own separate files. But if you can get there, then you can use a content security policy, which will give you huge benefits when it comes to preventing things like cross-site scripting and other forms of injection, okay? And so that is the place you want to be eventually. Now, when you're building new applications, if you can really work hard and be disciplined to not use inline scripts and styles, then you can turn this on and use it, and woo, everybody's gonna be super happy, okay? But if you have an existing site and you wanna move to this, that's your big obstacle, right? Is you gotta eliminate all that inline stuff. Here's a more sort of involved, complex content security policy. So in this one, we say default source self. Sure, that's kind of our fallback because everything can come from the same origin, that's okay. Images, though, can come from anywhere. So we can load images from any domain, anywhere. Media source, so this would be like video files and audio, stuff like that. They can come from media1.com or media2.com. And scripts, JavaScript files, can only come from userscripts.example.com. Gives us really great control over exactly where stuff can and cannot come from, okay? Now, as far as what are all the different things you can specify? So here I've got default source, image source, media source, script source. What are all the other options? Well, if I jump over here to content, or just do a search on content security policy, you can go to contentsecuritypolicy.com, which gives us a nice little resource reference here. So here's all our different directives. So we have script source, style source, image source, connect source, font source, object source, media source, frame source, sandbox, child source, plugin types, all sorts of good stuff. And then source list reference. So you can do things like wildcards or self or, oh, none. Oh. So you could have a web application that just displays static content. And so you can actually include a header that tells the browser you cannot load any resources from anywhere. Yeah, now the thing with content security policy, it's a relatively new thing, right? So it is supported by all the browsers, however, only at certain versions, right? So I put a list of version numbers up here. If your client is using a browser that's a version older than what's listed here, then it doesn't know what a content security policy header is, and so it just ignores it because it doesn't know of such a thing, right? So it won't be enforced. Now, I had somebody in the morning session who asked the question, okay, well then can I do something in my web application to tell the user that they have to use a certain browser and force them to use a certain browser? And somebody else in the morning session kind of laughed because they were like, yeah, we're not gonna be able to do that. So it's more of a political question, right? It would be nice if you could force all your users to make sure they're using at least these versions, but sometimes you have requirements where you just can't get away with doing that. But if you can, then you can. Basically what you do is if somebody arrives at your site, you basically look at the user agent string header, and if it's an older browser, redirect them to a page that says you have to have one of these browsers, right? And so whenever anybody tries to visit using an older browser, they won't be able to do anything, right? But you have to decide if that's something that you're actually able to do or not. But you know, yeah, okay. But it is up to the browser to enforce that content security policy header that you've sent down. How do you send down that header? Well, if it's the same CSP for your entire site, you can just do it at the web server level, right? You can go into the web server like I showed before, go into request headers, and then just type the header, the CSP header right into there, and it'll be returned with every request from that web server. Or programmatically, you can set the header value in code, okay? So you can just look at how to do that. So one of the things so one other thing first. So let's say you've got an existing web application and you'd love to implement CSP, but you know it's gonna be problematic. And you wanna make sure that you don't try to implement it and end up breaking a bunch of stuff, okay? Because you're not sure how much inline stuff is actually in use, and there is a way to implement this, by the way, and actually tell it to allow inline script, but if you're doing that, it's kind of defeats the purpose. So, but one of the things you can do is you can use a slightly different header, which is the content security policy report only header. This is really cool. And so basically what you're doing here is you're telling the browser, hey, there is a content security policy. Here it is, in this case, default source self. Oh, and here's a report URI. And so now what you're saying is, hey, browser, I want you to look at this security policy that I'm giving you and pay attention to it, but don't enforce it. So if the web page that's loaded loaded tries to get stuff from somewhere that's against the CSP, go ahead and let that happen, but then tell me. So send a message to this URL that says that there was a CSP violation. So the page still works, everything's fine, but then what'll happen is the browser will send this little chunk of JSON to that URL. In this case, it'll tell you that this was the URI that was blocked, here's the directive that caused the violation, and the policy. And so now you can you're gonna have to create the endpoint to receive that JSON and record it somewhere, but now you can have a list and see, okay. It'll also print out these violations in the terminal in the browser and like developer tools. So if you're just like running it locally, but this is kind of cool. So this way you can turn it on, be able to monitor it for a while, see if you have any violations, whatever, and then turn it into like enforcement mode if you like. So I put a couple resources up here, contentsecuritypolicy.com, the Mozilla reference documentation, which is really good. And also that last one there, observatory.mozilla.org. So this is one where, this is a really, really good one. So I'll show you what this is all about. So the Mozilla Observatory, what you can do is you can put a site in here. So we're going to put in dpw.lacounty.gov, and I'm going to click the scan button. And what this does, it basically makes requests to the site and looks at what's coming back, looks at the header that's coming back, and looks at a few other things too. And what it does, it gives you a grade, A, B, C, D, or F. And then it gives you a reason why it gave you that grade, and then gives you a whole bunch of links and resources you can look for how you can improve your grade. So let's see what grade we get. Oh, man. All right, so unfortunately, we got an F. Now, if we take a look at our scores down here, we can see why we got an F. So it said our score is actually 0 out of 100. Ooh, yuck. So if we start looking down the list, okay, so the very first one listed, it says content security policy. Content security policy or header not implemented. That means you lose 25 points for that. Second one, cookies, no cookies detected, so you don't get it, so there's no penalty there. Cross-origin resource sharing, content is not visible via cores, files, or headers, so no penalty there. HTTP strict transport security header not implemented. 20 more points you lost there. That's one that we're going to talk about in a minute. Redirection, so initial redirection is to HTTPS on same host, final destination is HTTPS, so you get a green check mark, no loss of points. Refer policy not implemented, but that's optional, so no loss of points there. Sub-resource integrity. Sub-resource integrity SRI not implemented, and external scripts are loaded over HTTP or use protocol relative URLs via source, blah, blah, blah. 50 points off for that one. So that's one where you're loading external resources from somewhere else, and you're not doing something to verify the integrity or that is actually what you're expecting to be getting. So this is done via like hash codes, digital signatures. X content type options not implemented, -5. X frame options, -20, and X XSS protection, -10. Now for each one of these, you can sort of hover over the little I and it'll tell you about what's going on. And then if you click on the link, you'll get a more in-depth breakdown of what this is, why it's cool, and how you would implement it. Now, for something like X frame options, so this header, it says, X frame options, an HTTP header that allows sites control over how your site may be framed within an iframe. Clickjacking is a potential attack that allows malicious sites to trigger users into clicking links on your site, even though they may appear to be not on your site at all. So basically somebody's masquerading as your site by hosting your site inside of an iframe. So by using this header, you're basically telling the browser, my site should not be permitted to be hosted in somebody else's iframe. This is an easy one. You can do this in 5 seconds, right? Just have your IIS web server or whatever return this X frame options deny header, or same origin, which basically means it can be hosted in iframe, but as long as it's on the same domain, right? And then boom, you get some points, right? Low-hanging fruit here. Now, there are some other ones that are also easy to implement, but then there are some others that are much more involved. So like the first one here, content security policy, like we're talking about right now, if you've got a whole bunch of inline scripts and styles, that's a tough one to get, right? Because it may involve a lot of refactoring and a lot of other stuff. So, but now some of these other ones, like this guy, strict transport security, we might be able to get that one, and we're going to talk about that one next, okay? This one also should be really easy, because if you're using things like Bootstrap and jQuery and stuff like that from other places, you just need to make sure to modify your script tag where you're pulling those in to include some additional information in that script tag that the browser can use to verify the authenticity of the scripts that you're pulling in, okay? So that should be an easy one to pick off. That's 50 points. And then of course, for each one of these, you can click on them and read more about sort of what kind of attacks are possible because of that, and so on and so on. But here's the thing I want to point out about this. There's another site that I'm going to show, which is this one called SSL Labs, okay? And this is going to do something related to how your servers configure when it comes to SSL. So let's take your site again here, and we'll put that in there. We'll not show that. We'll click submit. So we got a B. Okay, cool. And now we can look down, why we got a B. It says the server supports weak Diffie-Hellman key exchange parameters, grade capped to B. Oh, okay. But we might fix that, and then we realize that we still get a B. And then you do a little research and you figure out, okay, how would I get an A, right, or an A plus here? What you may find out is in order to get an A plus, you have to restrict your clients to only clients that support TLS 1.2. But then that excludes a whole bunch of older browsers. And so, making your site A plus may not actually be what you want, right? Because you're paying a price for that. And it's the same with sort of the observatory of Mozilla.com. In order to get an A there, some of those restrictions that you end up having to put in place could limit the functionality of what you can do in the site and take away some of your tools and stuff. And so the reason Accelerate still gets such a low score is the same reason I was telling you guys earlier, which is there are parts of the Accelerate site that have been around for a really long time, and we still have a bunch of inline scripts and styles that are slowly kind of coming off. And so what's going to happen is eventually, once we reach that threshold where we get rid of the last inline script and style, it'll go from like F, boom, straight to like B minus, okay? It's just taking us a while to get to that sort of point. And when it comes to like HTTP strict transport security, which we're going to talk about here, we have some subdomains that we cannot run over HTTPS for reasons that I won't get into, okay? And so because of that, we can't actually turn that on either. So there are just some practical limitations that come up. But content security policy, again, it's a newer thing, and sites are slowly working their way toward that. And so it's more something you should be aware of, you should look at, but not necessarily something you should, spend a huge amount of resources on, okay? But hopefully, as long as you know that's where you'd eventually like to get, it helps you make better decisions when it comes to like inline styles and, kind of things like that, okay? But yeah, I wouldn't, even though I put that up there and it's like, you guys get an F, don't worry about it, okay? But you should run the test and read those results and sort of have a handle on what each one of those things is saying to you. Whether you actually address them all or not, that's the second part, right? And you can be selective. Try to pick off the low-hanging fruit, take care of the ones that are easy, and then, the harder ones, maybe you get to, maybe you don't, kind of depends.